Today we'll learn about one chapter of class 10, that is effect of current. And under this chapter we'll cover some subtopic today, that are electric charge, properties of electric charge, electric potential and potential difference, and electric current. It is a big chapter, but today we'll only cover all these things. Later topics will be discussed on the later class. So follow today's lesson. Effect of current. Actually, the importance of the current, that is the electricity in our life, is enormous. Actually, effect of current in this chapter will cover heating effect of the electric current mainly, and apart from that, current has other two effects also, chemical effect of electric current, and also there is a magnetic effect. So we will confine ourselves, that is the heating effect of electric current and all these things. So first of all, we'll discuss about electric charge. If you want to understand what is electric charge, then we have to understand atom. Atom consists of proton, that is a positive charge, and some neutron, that is neutral. It is at the nucleus, at the core of the atom. Some electrons orbiting around the nucleus in an elliptical orbit. I have drawn here 1, 2, 3, 4, 5, 6 protons. So as the atom is neutral, so 6 electrons will be there also. 1, 2, 3, 4, 5, and then 6. So as a whole, atom is neutral of any substance. So if you rub any one substance with the other substance, then somehow the outermost electrons which are revolving around the outermost orbit are actually the attraction between the proton and the electron is light. That's why they can detach from the outermost orbit and go to the second substance. It depends on the pair of the substance, who will lose electron and who will gain the electron. If it loses the electron, so this electron will go to the second substance. So this electron, suppose how many protons are there? Protons are 6, electrons are 6. So if one electron goes to the next substance, then it will be, if one electron goes, then 6 minus 1, it will be 5. So 6 positive, 5 minus 5, that is 5 electrons that are negative. So what is the effective charge on the atom now? Previously it was neutral, but now it is positively charged. So now the atom charged as positive. So that is known as the electric charge. And at the same time, you can see the next substance with which it was rubbed, that substance is now negatively charged because extra electron goes to the next substance. So that's why charges are positive and charges are negative. These are the two types of charges. Now go to the properties of charge. Actually, what are the properties of charge? Then first, properties of charge. First of all, same charges, positive, repel, negative, they repel each other. And opposite charges attract each other. Positive, negative, attracted, negative, positive, attracted. They will be attract each other. This is the first property. Second property, total charge will be conserved for an isolated system. Total charge before reaction, after reaction, it will be conserved for an isolated system. Conserved. Charges are conserved. Number 3, charges are also quantized. That means total charge will be some numbers multiplied some integer with the charge of electron. It will be plus minus. Q is equal to plus minus Ne, where E is the charge of the electron, that is 1.6 into 10 to the power minus 19 coulomb. Okay. So if it is charge is negative, then it will be minus. If charge is positive, then it will be plus as a proton charge. So this is the unit of the charge. This is actually the smallest charge, that is 1.6 into 10 to the power minus 19 coulomb. But this concept actually developed, and we can show you it will be now integer, not only integer but also fraction. So we'll just confine ourselves in this chapter, that is integer. In the higher classes we'll learn it can be fraction also. So now go to the third thing, that is electric potential. Electric potential. So if we want to understand what is electric potential, we have to understand what is electric field. Electric field, what is electric field? Electric field. So if you place any charge, suppose I have placed one charge, that is plus Q charge I have placed here. So the influence of the charge will be felt around the region. Up to how much, the region up to which the influence of this positive charge will be felt is known as the electric field. Actually field is nothing but a region, and obviously around the point Q charge, this region will be a spherical region, and obviously there will be radius, a particular radius will be there. So this particular spherical region, the influence of this plus Q charge will be felt, and now we will understand what is electric potential. So we have placed one positive Q charge here, and we have taken one unit positive charge, and we have placed this unit positive charge at infinity, because at the infinity electric potential is 0. So have you read about gravitational potential? So if you put a body on this, then what will be the, suppose this is a surface, then if you put this body on this surface, then what is the gravitational potential? It will be 0, because mgh, h is 0. So if you try to move this body upward, then as the height increasing, the potential, gravitational potential goes on increasing. So we have taken the ground as 0 potential, but here we have taken infinity. Infinity is a 0 potential because inverse coil law. Now this positive charge we have placed here, and what is the field? I have told you this is the field due to this positive charge plus Q charge, and we're trying to move this positive charge towards this plus Q charge. What will happen? Because it is positive, it is also positive, so repulsion must be there. But up to this region, from this point to up to this, suppose we are moving this body from this path and going closer up to this region, up to this path, the body of positive charge will not feel any repulsion. Repulsion will only be felt when it just enters and goes inside it. So when the positive charge comes to this point, suppose this is A point, this is B point, no force is there. At the A point, no repulsion is there. B point, no repulsion is there, because it's outside the field. Now at the C point, you will see it will just enter the electric field and repulsion forces will start acting. Now at the point C, some forces will just start acting. Now if we go inside it, suppose this is a point D, it is the point, suppose D, then we have to do some work, because at each and every moment the positive charge will give some repulsion force to the unit positive charge. But if we want to go in this direction, then we have to do some work. We know at the class 9 we have read about what is work done. Work done is equal to force into displacement. Force into displacement. So in this way we can write force is equal to, F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. This is a formula, but this is not in your book, but force will be like that. So force into displacement. So in the opposite direction, force will be in that direction, and displacement to the opposite direction. So one negative sign will come, Fs cos 0 degree, that is 0, Fs, that is Fs. This type of work we have to do. So this work done, what we have done against the repulsion force, that will be stored on the unit positive charge as potential energy. So what is the summary? What is the conclusion? What is the potential energy? So potential energy is nothing but work done due to unit positive charge, because we have just bringing unit positive charge. So that energy is conserved, that energy is stored inside the body. Now remember, this body is just moving upward, then some energy will be stored inside this body, and if you release this body from that height, it will fall down. Okay, fall down. Why it is fall down? Actually it is the work has been done on the body, some energy is stored in this body, and due to the equilibrium condition it will not stay in this higher energy state, it will come down and go to the zero level. What is the zero level here? This is the zero level. Now show some work. Apart from this we have to do some work. So that is actually known as the electric potential. Electric potential. It is the definition. This is definition. Electric potential at a point in an electric field is defined as work done in moving a unit positive charge from infinity to that point in the electric field. Symbolically we want to represent it. It will be electric potential will be equal to work done. I have told you, but for unit positive charge. But if you want to move a Q charge, then you have to calculate for unit positive charge, because we have given the definition. Definition is set for unit positive charge. You can move any charge, positive Q charge. It will be divided by Q, because we have set our definition for unit positive charge. If you take Q charge, then do it for unit positive charge. So this is the definition. V is equal to W by Q, where V is the potential, W is equal to work done, and Q is equal to charge. So what is the unit? Potential, unit of potential is volt. Unit of work done, you know, that is joule, NSI. And charge, that is coulomb. So V is equal to W by Q. Now what is the potential difference? Suppose we had to understand this, we are taking 2 points. Suppose this is E point. Okay. So what is the potential difference? VD. VD means some work we have to do for bringing unit positive charge from infinity to this D point. Suppose D point distance is R and E point distances is R dashed. VD. So some work VD. And what is the potential at the point E? So it will be to bring unit positive charge from infinity to the point E. You see, E point is very closer to Q. So extra work you have to do. More work with respect to the D point you have to do. So what will be the potential of E point? That is VE. Which is greater? VE or VD? VE will be greater. Then potential at the point E will be VE and potential of D will be VD. Then what is the potential difference? Potential difference is nothing but VE minus VD. That means to bring unit positive charge from D to E. Now go to the electric current. You know, electric current is nothing but the flow of electric charge per unit time. So electric current can be defined as I is equal to charge, that is Q. Write down here charge, electric charge, that is Q, and time, that is in second. So this is the formula, I is equal to Q by T. I is equal to Q by T. So what is electric current? Electric current is nothing but the flow of electric charge from a point in a particular cross section of the conductor in unit time, that is in AC system it will be unit second. One thing you have to keep in your mind that current always flows from higher potential to lower potential. As water flows from higher height to lower height, you have not seen water is flowing in a upward direction. Always water flows from higher altitude to lower altitude, high pressure to low pressure, all these things. So here also current always flows from higher potential to lower potential. Okay, so this is the electric current. What is electric current unit? It will be ampere. Ampere symbol is A, capital A, because it is coming from the name of the scientist, that's why it is capital A. And charge, that is coulomb, COULOMB, that is, it is also coming from the name of the scientist, that's why it is coulomb. And now it is time. Time is in actually it will be second. Yes. Okay, so ampere is equal to coulomb per second. So this is electric current. Actually, electric current can be measured by ammeter. Ammeter is a device and always it will be connected in a series. Current, for measuring current, ammeter can be connected, only be connected with series. And voltmeter, what is the potential difference, potential, all these things? How do you measure? You can measure potential difference or potential by voltmeter. But voltmeter only be connected with parallel with the resistance. Okay, keep these things in your mind. Okay, up to this today. Next day we'll just discuss the next things. Up to that, if you have any question, mail me, that is Shubhashish Maiti physics @gmail.com. Thank you.